Okay, so this space shuttle is orbiting Earth. Space shuttle. Look at our lovely drawing. I want to know, what does the force equal? Well, this center-seeking force that is pulling us towards planet Earth. Oh, I gave it away. It's gravity. Okay, so the space shuttle, as it's orbiting Earth, it is literally falling out of the sky at every possible moment. But right when it starts falling, the Earth rotates away from it. So it's constantly falling, and constantly the Earth is also falling. So it's chasing. They're tied. So the weight force is what is keeping it in orbit. I hope that made a schmiddle bit of sense. I don't really understand it well enough to explain it that well. I'm not an astronomy person. And then this one, since both of these are so short, we're swung in a path with a radius r at a velocity v. What combination of changes would increase the center-seeking force? So that is mv squared over r. So if we want to increase our centripetal force, we should increase velocity and decrease radius. You can try this with real numbers if you don't believe me. But since this radius is like on the bottom of this fraction, decreasing it is how you increase that side. If you want more pizza per person, you decrease the number of slices that you slice it into. That's how that works. Okay, so we need to increase velocity, not having it, and decrease the radius. Not doubling. This one, you double the velocity and you halve the radius. That's the way.